What's up, guys? This is Pre-Calculus, proving functions have inverses. This is a Part B video, so we encourage you to go back and watch Part A if you need further explanation or just to review this concept with some extra examples. We're continuing to use question 17. We did question 16 in the previous video, but in question 17, we want to use function composition to prove that f and g are inverse functions for each other. By pushing the two functions together or composing the g function with the f function, we're able to see if, by the result that we get, if they actually are inverses. So for example, what you'll notice is that we're going to take the expression x to the third plus 1, that's the g function, and we're going to insert it into the f of x function wherever x is located. We'll do some simplification. If our answer that we get is actually x, then f and g can be demonstrated to be inverse functions in this fashion. All right, notice that I'm using the g of x notation to replace x in f of x. I could put the expression, that's what I eventually will do, but I just want to remind you that it's as well as x is a variable, g of x can also be considered a variable. It kind of actually follows from the fact that y equals f of x, that whole y equals is a variable and it is a function as well. So what you'll notice here is that I'm taking the expression for g of x and I'm going to go put it into x in the f of x function. Now by substitution, that means that I'm going to replace g of x with the expression that it equals. So I'm going to take x to the third power plus 1. I'm going to put that into the g of x space. Okay? So I have x to the third plus 1 in parentheses inside the cube radical function, and finishing out the rest of the situation, the minus 1, the cube root. If you think about it, those parentheses really don't do anything, so we can remove them, right? We can just take the parentheses off and have x to the third plus 1 without parentheses. That way we can see that plus 1 and minus 1 will cancel each other out. They sum to 0, leaving us with x to the third inside the cube root, and if you have a cube root of a cube, you end up canceling those two exponents out. That's right, cube root is a form of an exponent, and you're left with just x. When you compose two functions, and the result of composing two functions is a single x, that's how we prove that they are actually inverses of each other. We should also check it in reverse, just to make sure that we didn't just magically make a mistake and it worked in our favor. So in this case, we're going to go g composed with f, g of f of x. In this case, all of the f of x function is going to replace x in the g of x function. So that's the cube root of x minus 1. That expression is going to go into x to the third plus 1. We see that as make the f of x become that expression. Cubing a cube root cancels each other out. That allows us to provide x minus 1 in context with plus 1. Minus 1 plus 1 is 0, so we're left with just x. And there you have it. When you compose two functions in either order, you wind up showing that, well, if the result of doing that is x, we can say without a doubt, with mathematical proof, that those two functions are in fact inverses of each other. I encourage you to graph it, put them in Desmos. You'll notice that they kind of like reflect over the line y equals x, but that may be for another video. Thank you for watching this video, and catch you on some other ones. Thanks, bye.